basically the session is just a small session on how to read a research paper. So this is like, you even do it without a session as well, but just that it will be like helpful for you guys to start, because even initially we also read many papers, and like maybe like we got to know many things after reading many papers. So we thought we'll just put on all the points what we think are a very good methods. Like there's some small tips here and there, like so that you can use them right away, not like waste time reading papers in the wrong way and then maybe again come back to the correct way. So we just put on a small like presentation kind of thing. So why do we read a paper in the first place? So there are three main reasons why we read a paper. So it's for a competition or for a project where you have some specific goal, where you have some specific target. So assuming we have 5 projects, right? So one of them is text to speech for Sanskrit, one of them is visual question answering, one of them is denoising of point clouds, one of them is text guided hallucination, like rendering, and then like another is like for reinforcement based thing, right? So those are some target you have. So you have a specific domain for what you are trying to do. So you want to look for papers which are bit and which are like which are like, you are looking for papers where they have done some work in that area, and you want to see what has been done. So this is very important for a competition or for a project. But in this case, we'll be looking, because for you guys, like you'll be looking for a more of project specific. So everything what I'm talking next will be like more of a project specific thing. So yeah, where you're looking for a set of papers, which yeah, right, something like that. And like you are looking to know what has been done in the past, because sometimes if you know what has been done in the past, you can see what is the good things from the past and what is the bad things from the past. So that is the thing. And then yeah, that is for the first reason I read a paper. Yeah. The second reason is to increase the knowledge. So sometimes we just read a paper just like that. We find some good paper, something recent, very, very good paper. Sometimes we just like find in the internet, something like that. There's like a lot of like what news about that, something like that. Then we may read the paper, something like a really good paper which is released. Then we can read the paper just to know what like some new innovations in that field, something like that. Just like, but it's this not like some project specific or something. It's just to increase your knowledge in that per se. And one more reason, like, not a very important reason, but yeah, kind of like when you read a paper, you may encounter some topic or some concept which you don't know, but it links to another paper. So assume something like UNet. This is a paper called UNet. It's an architecture. So they may say that we use skip connections like DenseNet. So you may not know what is skip connections. You may not know what is DenseNet, but they might have linked the paper as DenseNet. So you can read the paper and understand what skip connections. So this is another reason why you may read a paper, but yeah, again, that's not like very like, majorly you will read a paper. So what we'll be concentrating on this entire presentation is the first thing, that is you are looking for a project. You have a project in your mind, and you are looking for paper specific to that project, right? So like based on something, I will just collect based on some information from another paper. Like there's a paper called How to Read a Paper. So they have mentioned something. So I just like jot down all the points from there and made a concrete like kind of an thing you can follow to read a paper. So there are 3 parts which you can make to read a paper. The first pass is to make like to give you an idea whether to read the paper or not. So sometimes you may find a paper, but it may not be relevant to your thing. So that's the first pass. So you may reject it or like you may read it further. So that's the first pass. Second pass is like where you get a concrete understanding of what exactly is happening in the paper, what is the novel contribution of the paper, like what they have done newly, what is the paper about, everything. You get a full idea. Basically, you read the entire paper and you get an entire idea of what has been done in the paper. The third pass is optional, not required every time, but it gives you very inner details of the paper and also lets you know sometimes some hidden information which the paper doesn't give you. But while doing the third pass, you will get to know very many like hidden findings which the paper doesn't like when the author doesn't mention in the paper itself. So that's when the third pass comes to the picture. So the first pass again, like, so like now we'll go to each of the passes more detail. So the first pass is to let you know whether to read a paper or not. So this is very important when searching for papers. So I think so like when you what will happen in every project is like you'll be told to do a literature review of all the papers, or what like so you'll be told to collect papers and read them. Okay. So while collecting papers for a domain of the project, so like if you take AONH, it's like visual question answering. So you'll be told on uh, collect papers on visual question answering. So while collecting papers, you may find something relevant, but you may find papers which similar to the concept, to the topic, but may not be relevant to you. So you may reject it. So that is where the first pass comes into the picture. So when doing the first pass, you read the title, you read the abstract, you read. So with these two things itself, you'll be able to understand whether to go further. Okay, the title and abstract are more than enough. But if you still a little get confused and okay, still not able to understand, introduction is a very good thing because they'll explain what they're trying to do, what problem they're trying to achieve, what's the problem actually, all the things they try to say. So introduction is a very good thing in that sense. And diagrams, so some model architecture, some data set diagrams, some results. So it'll show some diagrams will be there. So if you look at them, you'll understand. Okay, this is what even we are trying to do. This is very good. We can also try to. So diagrams also give very important clues and hints when reading a paper. So after you do the first pass, you will come to a conclusion of like you'll come to three conclusions. Like one of the three conclusions, whether to read the paper now, that is you think that is relevant to your domain and you want to read the paper now. The other thing is you may not have domain knowledge right now to read the paper. Like so it's very difficult or maybe little higher understanding. So for example, there's a paper called maybe some transformer based encode decoder model for visual question answering, something like that. Assume we have something like that. So at that time, we may not know what's transformer itself, right? So you may keep the paper for now, read about transformers and attention-based model, and then again come back to the paper. So something like that. The third part is you just leave the paper, you reject the paper, think like saying that it is not relevant to your domain. So the bottom flowchart just gives you a summary of what is first pass, helps you to understand what is the conclusion you'll be going over, right? A small flowchart kind of thing. So after the first pass, assume you go to the second pass. That is, you like the paper, you start reading the paper. So the second pass is to get the novel contributions of the paper and see what they have done exactly in the paper, and see, so to understand the model architecture, what data set they have done on, what is their like what is saying. What methods they have used, all these things come in the second pass. You get a clear understanding of that. So for doing the second pass, so yeah, basically, second. Sorry. Yeah. So for while doing the second pass, you'll be reading the entire paper. So while at that time, it is better to make notes and references. Something like you mark, you highlight some points, you say this is good, this is bad, you may not understand, something like that. So while that you can do in two ways. One is you can just like use some PDF editor, something like that, and online you can do it. That's one thing you can do it. So using this online, don't need to take printouts. So the other way is to take a printout and read it out. So that is up to you what you prefer. So initially I used to take printouts and read it. So but then I thought that like it's just piling up unnecessarily so much paper, so I stopped it and I was reading online. So but I think initially initially you can, if you told you have that option, you can take printouts according to again preference. Sorry. Yeah, so it's all according to preference. If you want to take a printout, you can take a printout, or if you want to take if you want to read it online, you can do it. So while doing the second pass, what you do is you make notes. So you write things. Okay, this is a good thing. We can implement it in our paper, like in our model. Like when you try to do in your project, this is a good thing. What is this thing? This not able to understand. I'm not able to understand this. You'll mark it in red or something. You'll write, basically make lots of notes, so that later when you come back to the paper, you get a good summary of it. When you read the paper again or something like that, you get nice understanding, because these are the good points. You don't need to read the paper again, so it's very good when you again try to come back to the paper. So making notes is very important, like marking something like that. So initially that's very important to mark notes. So I'll tell you. So basically, like if I come back, right? So, yeah. So this is a paper. So this is what I have done, like kind of thing. So I had like basically some important parts are there. I have marked it in yellow. So like something like that. Okay. So it's like something like so star means this is a really good thing. Something's there. Red means I don't know. I'm not able to understand what they're trying to do. So if I mark it for now and later I can go back and check what is happening. So something I just make notes here and there. Okay, this is the thing. So if we take some other paper, so like like I just make notes. Like you can just understand like. So here and there, like so I mean we can even use different highlighter, like yellow means good point, green means really good point, like they've done really novel thing, which is really outstanding. So something like that you can try to do. So different color ways you can try. So it's just an example I'm just showing you what all can be done. Right, just an example. Yeah. So you just think what is the motivation behind this addition. So why are you trying to do that? If you write it down right now and later you can come back and you can think on it more and more like that. It's basically like that. Right. It'll give you more better understanding. So at the end of second pass, you'll have a clear-cut idea of the things which they have done in the paper. So you'll get a very good understanding. So now from this, you can again take three conclusions. You will land into one of the three conclusions. So one is that okay, you find very good ideas on the paper, you mark them down, and you'll try to use them in your own project or something like that. You'll try to incorporate those ideas in your own model architecture, something like that. So that's one thing. Second thing is to leave the paper. So that is when you think that okay, the paper is good, it is in my own domain, but nothing novel about that. It's okay, my paper only, not that good of a paper. And the third point is the third pass, where you go to the third pass. That's to implement the paper. So the third pass is optional, not necessary. You should not do it for all the papers, but I recommend doing it for like maybe like one or two papers initially, like when you're like right now in a beginner stage of reading papers. It is very important. I think at least one paper in your own domain, if you just implement, right, it'll be even useful for your own coding skills as well as you'll get a lot of understanding of your own domain. Because sometimes what happens is in the paper they don't give you a lot of details like fine details. They just like just give a very shallow detail. Okay, this we have implemented this convolutional network, this transformer, like something. So you may not know how many channels they have used, what is the activation function, that this, so many things will be hidden. So when you do the second pass, you'll not concentrate on what is the channel size, what is the kernel size, what is padding, what is that. You'll not concentrate on all those things. We just concentrate on the overall architecture, what they're trying to do, what they're trying to achieve. But in third pass, you'll go to all the finer details. You'll go so deep into that. So this will give you a lot of ideas. Like so, this will also will be very helpful while doing your own project also. Like because because you have implemented a paper similar to the domain which you're working under. So when you try to implement for the like when you try to code your project like model architecture for your own project, it'll be very easy because you know you written a code. You know some finer details, what to do, what not to do. It'll be very useful for you at that time. Yeah. So so the third pass can be of two types. One is implementing the paper without seeing the source code. Usually the source code will be given in the GitHub. So you can either directly copy paste and do that. There's no use of it. Right? They're giving the code and you can copy paste and do it, but there's no use. So one thing is just by reading the paper, you try to implement the paper. Just by don't see anything else, just by reading the paper, you try to implement the paper directly. This will give a very good hands-on experience. Okay, this is the thing. And the second thing is just going through the source code. Even so, this is a useful later stage. Like not maybe initially you it's better to implement a paper like in the initial stage, but once you implement 2 3 papers and it's like enough like of implementing, you can just go through seeing the source code in the GitHub. So that will give you a lot of ideas because sometimes they may not mention those ideas in the paper, but after seeing the code you'll understand, okay, this is what they have done. It's a very good idea they've used, like some finer details, some inner details which is not given in the paper. So that you'll be able to find out reason when going to the source code. Right. So yeah, this is what the third pass will be like. It gives a lot of insights about the paper and gives you future work. So about so because you implemented it, so now you can try to implement the same block or same modern architecture for your own project. So it will give you a lot of ideas for future work for a project. And when since you have coded the paper on your own, this will give you a very good hands-on experience to code and all. Like because sometimes you not be lost on what is like how to code data loader, modern architecture, training, how does it work, and a lot of things will be there. So if you if you try to implement one or two papers in your own domain, it will be very useful for later purpose as well. So yeah, this is an overview of the three pass method of reading the paper. So a small tip here and there, like while reading a paper, is like initially, like when you are reading right in this stage, in your stage right now, when you're new to the field, while reading a paper, try not to go over like previous work, related work, and all that. So, for example, if I take a paper, yeah. So in this thing, don't go over this part. Is what I'm trying to say. So don't go and read this part because this may be confusing initially because you may not know what is this ALS data, what is this all these things will be like very new to you. Like it'll be like because they'll use all new terminologies in these things. Okay, and you'll be confused totally, and they will like you may lose motivation to read the entire paper. So initially, I would suggest to not read that part of the paper. Other part you can read, not any issue. And one more thing is, if you get stuck and not understand any concept, something like assume transformer models. Okay, what exactly they're trying to do? What is QKV in transformers? So you can go and check out YouTube videos or Medium articles are there, True Data Science articles are there. You can search through them also. You can read the articles and get a more understanding of the concept, right? And you can again get back to the paper after getting to know the concept. So that's the thing for like when reading a paper. So yeah, so the best ways to search for papers is Google the keywords you're searching for. So giving like an example for a project. So like if you take the Clean the Lidar project, it is like denursing of point clouds in a supervised or unsupervised fashion. So that's like the keywords which are there. Like for if you take the EONH project, then you can say like visual question answering like that. Something like you can try. Like okay, like that. Like so we can have like keywords for that. You can try those keywords first and try to get as many papers from that and try to read them. And I recommend first reading conference papers because they're more authentic than reading archive papers directly. So if they're conference paper, it's really good because they're of high standards and they'll have very good quality and you'll learn a lot from them. So than a normal archive paper which has not been published. So I'd recommend you to read in conference papers first, finish all the conference papers, and then come back. So again, there's other way is also papers with code. It's a really good website where you can get a lot of things. So if I come back, so if I write visual question answering, like assume I'll just say visual question answering. Yeah, okay. Papers with code. Okay, I just googled it some time ago. So it will be there. So papers with code, visual question answering will be there. So we just go there. You'll see this paper. So you feel a ton of papers which they have collected. It's like a repository they have kind of thing. And you don't have to search here and there to find again where it is. Everything is there in one place almost kind of. So these things you try to read. So here if you see that it is given some ICCV. This is the conference name, ICCV, CVPR, ICCV. These are good conference. So you can try reading these papers first. Well, these are like most implemented. Like these are like very good papers. So you can try reading these papers first, and then you can go to latest papers, and then you can try reading these papers. So the latest very latest 6th July, which is like just 2 days ago. Yeah, it's just 6th July, just 2 days ago. It just came 2 days ago, if I'm not wrong. Yeah, it just came 2 days ago. And it's like so, and it's been very good paper. So you can try reading the uni paper. So right, these papers have come very recently. So you can try reading those papers in this fashion. So similarly, if I tell for other projects, so for the Pingala project, so text to speech papers with code, if I just right. Okay. Yeah, you'll get it. So any domain, they have a good repository. You can just go there and they have a lot of papers on them. So again, so you can try most implemented. These are like famous paper. These are like very good baseline papers. So you can try reading one or two of this and then you can go over to latest papers. These are like very new papers which have been recently released and you can read these as well. Right. So that's the thing. So papers with code and archive sanity, it's again a collection of papers. You can check them, you can check it out, but I don't recommend it like as such. But yeah, I just mention it. If at all you like them, you can read it. Yeah, and also while searching for papers, try not to go beyond 2018. Like don't go try searching papers for 2017, 16. Don't read them because they're very outdated. Like 2017 means like 5 years old, right? Which is like very bad. So like try to limit yourself by 2018 maximum by 19. Okay, don't go beyond 2018 like that. Try to give it like about 2018 and 2019 because the thing is usually the new papers like transformer based model papers are usually the new papers. They're not the old papers, and like transformer based models are what is emerging right now. Everyone is using attention based models, so it's more important to read recent papers than to reading old papers. But you can read some old papers which is like some very good papers like ResNet, UNet, GAN, like the original papers where they explain the main thing, fundamental of the thing. Then you can read this. Then you can read those papers. So in this thing you can just saw that. So basically, so Tacotran is like a baseline paper for like speech, text to speech. It's a very good paper, and it's a very good paper. So you can, so even though students 17 paper, you can just try reading one or two papers based on that, like that basically. Not like anything fun. But yeah, this is what a summary of like, I mean, a small thing on what I had to present on how to read a paper. If you have any queries regarding it, we can discuss. Yeah, and also one second, I'll just share you one more thing. Uh, yeah, screen is visible, right? If someone can confirm.
Yes.
Yeah. Yeah, cool. So basically, what we have thought is like after you read a paper, you'll be told to summarize it in this fashion. So after you read a paper, you write like topic, okay, what is the problem they're trying to solve, an overview of them, so the model architecture, what is their method solution, what is nice about their method, what could they have done better, data set they have used, all these things you can try adding. Like basically, it's like a very good summary of a paper. So rather than writing summary, right, stories about the paper, like okay, they have done this thing, they have done this, that, oh, like big story, and it will be very difficult for anyone to read also later in future. But if you make it in this fashion, right, it's very good, right? So what's the problem? It's very concrete. Okay, problem is this is the solution, this is the nice part, like novel part, nice part of the solution, this is what they could have done better, and we can improve it in our project as well. So this is a data set they use, we can use these data sets, all these things are given, right? This you can understand, right? So we will share this thing. Everyone will, I think every project will be mostly following this pattern, I guess. I'm not sure. Yeah, we'll be following this pattern of like adding papers and and summarizing them in this fashion. Yeah, this is it, and we'll be sharing this to you. Yeah, but this is like it's a very concrete, and because if later someone else also wants to read about the paper, instead of reading the whole paper, they can just read your explanation of the paper, like method, nice about the method, and what could they have done better, improvements. It's a very like small, like easier way to read a paper, like very good thing. This is the good thing. And you also, when writing summary, right, you'll also get to know very, like you'll again read the paper, like when writing summary you'll again think about the paper, okay, oh, this is what they have done, so you'll again like think twice about the paper. This is also good. Again, this also revise, this also make you revise about the paper, and very good, like also like when you write all those things. So yeah, in that way it's really good. So yeah, I think this is about the paper reading.